All right, I thought we'd do some practice problems today from Chapter 2, things that you'll see in the Chapter 2 homework. So I picked a couple of those problems off and thought I'd solve some of those here. And anything else you wanted to go over. Exams a week from today, so we should be pretty comfortable by now with at least dimensional analysis. So I wanted to do a couple more problems today that were maybe a little bit more advanced, like the one we did at the end of class today. So with that, let's just jump into it. And we'll consider this dimensional analysis problem. Dr. Melko is 76 inches tall. How many nanometers is that? And you're given the equality 1 inch is 2.54 centimeters. Right, so as I approach all these, the same way, I'm going to write what I need to know on the very far right side. Right, so some number I know I need to get in nanometers, pardon me. And I'm given on the left 76 inches. So I'll just write that here. And now I need, to use unit factors in the middle here. And of course, I'm given 1 in the problem, right, which almost guarantees that I'm going to use that at some point in parentheses as a unit factor. Okay, and so I'm just going to write my first set of parentheses here. I might need more than 1, so I'm going to leave myself room. And I'm just going to write in here the following. Okay, in all these dimensional analysis problems, usually whatever you're starting with is going to be in the denominator right away. Okay, whatever you're given here is almost always going to appear right away here. Okay, so just go ahead and write it in there. Okay, we know we need to put something in inches there. And so what unit factors do I know? I don't really memorize many unit factors for inches, maybe 12 inches in a foot, but that doesn't really help me here. The one I'm given in the problem is 1 inch is 2.54 centimeters. So I'm going to go ahead and write the 1.00 with the inch and the 2.54 above that, right? Whatever's in a unit factor here has to be equal to one another. So 2.54 centimeters in 1 inch. Okay, so what else do I know? Clearly, the inches here are going to cancel, right? I have an inch in the numerator and the denominator. That's going to cancel. And I'll be left with centimeters, but I don't want centimeters. I want nanometers. So clearly, I'm going to need another unit factor here. Okay, it would be nice if I knew how many centimeters were directly in a nanometer, right? Because then I could just set up centimeters down here to cancel and leave me with nanometers. Right, but maybe I haven't memorized exactly how many nanometers are in a centimeter. Remember that table in the book we want to memorize relates everything back to the base unit. Okay, so if you don't remember how many nanometers are in a centimeter, and I don't know why you would, people don't typically memorize that, but what they do memorize is how many centimeters are in a meter. Okay, and hopefully by now, or perhaps you're already familiar with 100 centimeters in 1 meter. Okay, and now I see where I'm trying to go here. I've gotten rid of inches by putting it in centimeters. I've gotten rid of centimeters by getting it into meters. And so there's got to be one last step here, because ultimately I need this thing in nanometers. Right, and here come the arrows again. Whatever you're asked for on the far right side, that's almost always going to be the numerator, the top unit, in your last set of parentheses. Right, so I know I need to wind up with nanometers in the numerator. That's fun to say. And the equality I might know is how many nanometers are in a meter. Okay, and that unit factor is convenient because that meter in the bottom will cancel with this meter in the top. Right, and nano sounds like 9, and that's how I've memorized it. There's 10 to the 9 nanometers in 1 meter. Okay, now I'm prepared to solve the problem with my calculator, multiplying across the top, so I'll do 76 times 2.54 times 1 meter times 10 to the 9th. And I get some giant number, and I'm going to divide by every number in the bottom. Okay, divide by 1 is still the same. Divide by 100. Divide by 1, still the same. Again, so all I've done here is multiply 76 across the top by 2.54 times 1 times 10 to the 9th, divided by 1, divided by 100, divide by 1. And what I get out at the end is this big long number in my calculator. Maybe yours truncates it, but mine looks. Oh, there's a 0 in here. 0, 0, 0, 0, 0. I swear eventually I'll get better at drawing on this thing. Probably not, false promise. But this is the number I get in my calculator. Okay, maybe yours truncates it with scientific notation already, which you need to know how to do. If not, and it gives you this long number, you need to know how to express this in scientific notation. Maybe that's all the answer is in. And so I look back here for sig figs. There's 2 sig figs in 76. Everything else here either has 3 or is an exact conversion, so I ignore it for sig figs. And so 2 sig figs is what I want to limit myself here to. So I know scientific notation says I'm going to write that as 1.9. Make that a little clearer. Times 10 to some exponent, and the exponent is how many places I have to move the decimal from here, where it's in scientific notation, to where it was in this big long number. And it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 1.9 times 10 to the 9 nanometers. Okay, so that's my final answer. That's how many nanometers I am tall. Okay, so you need to be able to do these unit conversions between English, inches, and metric, and that might contain some, metric to metric conversions within it. Okay, but the setup and the analysis is always the same for these dimensional analysis problems. Okay, if you're still having trouble with what to orient where, you need to follow this setup here that whatever you're starting with, you're going to have to get rid of that unit, and so it needs to be in the denominator here, right? An inch divided by an inch will cancel, right? A centimeter divided by a centimeter cancels. You want to be left with nanometers up here next to a number, so it better appear in the top. Okay, and there's lots of YouTube videos if you just Google dimensional analysis or YouTube dimensional analysis. You can get lots of practice problems in that way. Okay, the second one I wanted to do involves density, which we discussed today. Here we have a sample of silicon, which weighs 1.4 kilograms and has a density of 2.33 grams per cubic centimeter. So what is its volume in milliliters? Okay, so there's a lot going on here, but I'm still going to approach it the same way, right? What am I asked for? Volume in milliliters. There it goes on the right side. Okay, what am I given? Well, I'm given a weight and a density, but you'll remember this density, often said in class, can be used as a unit factor. Okay, what we're given or what we're told is this sample weighs 1.4 kilograms. Okay, that's what's going to go on the left here. Okay, so now somehow I have to get rid of kilograms and end up in milliliters. Okay, what I have is a density which will give me from grams to cubic centimeters. And one thing I didn't mention in class and sometime in the homework, it sort of assumes you know this. I'll have to specify on a test, I haven't told you in class, but one thing that you'll learn that is equivalent to each other is that 1 cubic centimeter is exactly equivalent to 1 milliliter. Okay, so a lot of times in the homework, they might ask you to go from cubic centimeters to milliliters, but it's really the same thing. Okay, if you have 500 cubic centimeters, you have 500 milliliters. Okay, so although in the homework problem you asked for volume in milliliters, that's really the same as if you were asked in cubic centimeters. Okay, which is convenient because that's what our density is given in, right? We have this unit factor 2.33 grams per cubic centimeter. Now I know to get from a mass like kilograms to a volume, I have to use density. So I know in here my density is going to be used as a unit factor. Okay, but what do I always say? This unit that I start with is probably going to have to appear here. Okay, so I should start by trying to cancel this kilograms, right? I don't want to start with the density right away because the density is not given in kilograms, it's given in grams. Okay, so let's get rid of this kilograms and get this in grams first. Okay, and we'll remember that there's 1,000 grams in 1 kilogram. Okay, and now that takes care of my kilograms and leaves me in grams. Okay, now I'm able to use this equality, grams in the bottom, cubic centimeters on top. Right, this is where a lot of people make mistakes. They might try to write 2.33 in the numerator, right? But 2.33 comes with grams, so it always has to appear with the G, with grams. Okay, so 2.33 needs to go down here. And there's that many grams in 1 cubic centimeter. Okay, and that'll take care of my grams and leave me in cubic centimeters. Right, I'm asked for it in milliliters, but remember, whatever it is in cubic centimeters is going to be the same in milliliters. You know, if you want to be explicit and use one last conversion here, right, to follow our explicit dimensional analysis, one milliliter equals 1 cubic centimeter. Okay, so I can give this third unit factor here just so I'm explicitly canceling that cubic centimeter and converting it to milliliters. Okay, but it's just 1 milliliter over 1 cubic centimeter. All right, so now I have everything I think I need, and I can double check that kilograms went away and left me in grams. I then canceled grams and left me in cubic centimeters. I then got rid of cubic centimeters and left me in milliliters. Okay, so that's the roadmap. Now I multiply across the top, 1.4 times 1,000 times 1 times 1, and divide that by 1 by 2.33 by 1 centimeter. And what I get is 600.85836, yada, yada, yada. How many sig figs do I need? Given 3, 1.40 kilograms. I'm given 3 in my density. Okay, everything else is an exact relationship. All right, so I should have 3 sig figs in my final answer. So that's a sig fig 6, that's a sig fig 0, that's a sig fig, my third one 0, but I have to look and see that it's 0.8. That 8 is greater than 5. So when I drop all these, I have to round up this to a 1. Okay, so my final answer here should be 601 milliliters. I rounded that 0 up to a 1. All right, so remember sig figs and rounding in all your final answers. Do the calculation in your calculator, bring all the, 7, 8-digit numbers along, and then at the very end, when you're ready to report your answer, then consider sig figs and rounding. Okay, so remember this. If you need it on an exam, I would give you this, but sometimes in the homework they don't give it to you and just kind of expect you to know 1 cubic centimeter is a milliliter. They talk about it in the book, so it is there, but just be aware of it. All right. Last one I wanted to do here is a fun one. Fun is a relative term, but I think it's fun. The sun is 93 million miles away, and light travels at 1.86 times 10 to the 5th miles per second. So how many minutes are required for sunlight to travel from the sun to Earth? All right, a lot of words, but again, what am I boiling it down to? I'm just going to circle the data of interest here. 93 million miles and 1.86 times 10 to the 5 miles per second. Okay, question in the chat, do we consider sig figs in our final answer every time? Yes. Whatever, is asked for in the final answer, right, on the exam, it's going to be multiple choice, but you need to be considering sig figs because you can bet some of the choices in multiple choice are going to rely on you knowing sig figs, right? In this previous question, right, the multiple choice, there probably would have been 600 would have been a choice. 601 might have been a choice. 600.9 might have been a choice, right? So if you thought there was 4 sig figs, you might have circled this one and been wrong, right? If you knew there was 3 sig figs but did the rounding wrong and circled this one, you'd be wrong, okay? It's only this one that applies the rules of rounding and sig figs. So yeah, we always need to consider sig figs in our final answer, okay? On the homework, it's a little more generous. I think it'll either tell you correct, but looks like you rounded to different sig figs. Like I think that's something it says. It'll probably accept the answer, but just give you a note, some feedback that says looks like you rounded to different sig figs, or it looks like you reported in different sig figs. Or it might say incorrect, no penalty, which means you kind of got the right answer, but go back and fix the sig figs or your units or something like that. Okay, so a lot of times it might say incorrect, no penalty, in which case you probably have a unit error or you typed a comma instead of a period or something like that. So hopefully that answers your question, Michaela. Coming back to the current problem, the sun is 93 million miles away and light travels at this 1.86 times 10 to the 5th miles per second. Okay, first thing I'm going to do is write these down as numbers, right? Just write them out so I can see what I'm working with. 93 million, I can write out the zeros, or I can write out in scientific notation. That's going to correspond to 93 times 10 to the 6 miles. All right, so there's one bit of information. The other is 1.86 times 10 to the 5th miles per second. Okay, and this is something you need to get comfortable with, that this per indicates that it's divided by miles divided by second, which I'll just write an S for, right? Just like mph, miles per hour in the car, or LPG, liters per gallon, right? Means it's the first unit divided by the second unit. Okay, so this, speed here, miles per second, looks like it could probably be used as a unit factor, right? 1.86 times 10 to the 5th per 1 second. Okay, so that might be something we need. Overall, we're asked for how many minutes are required. Okay, so we know on the right side here, it's going to be our unit in minutes. And what we're told is the sun is 93 million miles away. Okay, we're also told that speed of light, 1.86 times 10 to the 5th miles per second, but writing it out, we see that's more of a unit factor. So I'm not going to start with that. I'm going to start with this other given bit of information, 93 million miles. Okay, maybe here I'll write it out the other way with all the zeros. All right, so let's use a unit factor here. Do I have a unit factor that has miles in it? Because I know miles should go down here. And yes, I have this unit factor here, so I'm going to write the 1.86 times 10 to the 5th miles. See if I can cram that in here messily. Almost as bad as my writing in class. 1.86 times 10 to the 5th miles. And what goes in the numerator? Well, the other side of that unit factor, that 1 second. Okay, and now the miles will cancel out. And I'll be left with second. Ultimately, I need to get to minute, and I'm not told this, but I will expect you to know a relationship between seconds and minutes. Okay, I know I have to use this because right now I've gotten to seconds, and I'm going to need to get rid of seconds and get into the unit in my final answer here, minutes. And of course, 1 minute has 60 seconds. Okay, so here I go. I can now multiply across the top, 93 million times 1 second times 1 minute. Okay, which of course is still just 93 million. And then I'm going to divide that by these numbers in the denominator. And be careful with this one, 1.86 times 10 to the 5th. Okay, use parentheses around it if you have to, right? It's easy to get your calculator confused and not do the division right. Okay, so I like to do 93 million divided by, and then put parentheses, 1.86 times 10 to the 5th, close parentheses. Okay, maybe you have a calculator that doesn't have parentheses or works a little different, but you need to be able to enter this in your calculator, the one you're using on the exam, so that it's giving you the answer we get at the end here. Okay, so that's why you have to put pen to paper. You have to work these things out with your calculator, right? Without notes around, try to recreate that test environment so you can make sure on test day you're not, getting into these little problems, because I'm not going to be able to come over and help you with your calculator on exam day. Okay, so again, 93 million miles multiplying across the top. Those are just ones, so I don't even really have to do that multiplication. Divide by the number on the bottom. Use parentheses around this scientific notation one here so that your calculator understands what you're meaning. Okay, so 93 million divided by 1.86 times 10 to the 5. I usually will hit enter at that point before dividing the second number, which is 60. Okay, so after dividing by the scientific notation, I get about 500, and then I divide that number 500 by 60. Okay, or you can do successive ones in your calculator, but any way you do it, you should be winding up with 8.3 minutes. And it's going to say in your calculator 8.333333, repeating forever minutes, but you need to terminate that to sig figs. How many sig figs? Well, I'm given 2 in the problem and 3 in the problem. Multiplication suggests I choose the lesser sig fig, so just 2. So instead of 8.33, repeating, of course, minutes, I'll just truncate it to 8.3, the 2 sig figs. Okay, so 8.3 minutes from when the light leaves the sun before it reaches us. Okay, so as you're listening to this, sunlight that's leaving the sun will get here 8.3 minutes from now. Okay, and the sun that you're looking outside and seeing being reflected off tree leaves or whatever, that left the sun 8.3 minutes ago. Pretty neat. Okay, so that's an example of dimensional analysis, maybe not applied to atoms and molecules and masses, but still tells us something about the natural world. Okay, so I think that's all the practice problems I have here. I'll stick around for a little bit as I do some other stuff and answer any questions if you have them in the chat room. So, feel free to ask questions if there are particular homework problems you want to see worked out. That's fine. Otherwise, I'll stop the recording here. All right, see you.